Welcome to the deep dive. Today we're about to challenge pretty much everything you thought you knew about fats. Seriously,
Yeah.
forget the old rules just for a moment because we're diving into the fascinating and frankly pretty surprising world of pentadecanoic acid. You might know it as C15.0.
Mhm.
Now, this isn't just another nutrient we're talking about. It's actually being called an essential nutritional orphan, which sounds dramatic, right?
It does.
And our mission today is really to uncover why it's so unique, maybe why it's sort of vanished from our diets, and why it's potentially really crucial for your health, like right now. We'll be pulling out the most important bits from a whole stack of recent research, trying to turn that complex science into something clear, actionable, and hopefully full of those aha moments.
Absolutely. And what's truly, I think, revolutionary here is how C15.0 just directly confronts so many long-held ideas about diet. I mean, yes, it is saturated fatty acid technically, but its structure, its specific structure, gives it properties that fundamentally set it apart. It really seems to be a critical component that's largely, well, disappeared from modern diets.
Okay, let's unpack this then. The C15.0, yeah, it does sound a bit like a secret code. What exactly are we talking about here? Lay it out for us.
Okay, yeah, happy to. The C is simple. It just tells us it's a fatty acid, built from carbon atoms. The 15, that's where it gets really interesting.
Mm.
It means there are exactly 15 carbon atoms making up its backbone, and that puts it in a pretty rare category called odd-chain saturated fatty acids, or OCSFAs,
Odd chain. Okay.
right? Most of the common saturated fats, the ones we usually hear about,
Mm.
they have even carbon counts like 14, 16, 18 carbons.
Right, right.
And the zero, that just means zero double bonds between those carbon atoms. So it's saturated, fully saturated with hydrogen. And that's key because it makes it incredibly stable.
Okay, so that odd number, the 15 carbons, that's the key structural difference. And you mentioned stability. Why is that specific stability so important for our bodies? What does it actually do?
Well, its shape, it's linear, it's compact. And that configuration allows C15.0 to pack really efficiently into our biological membranes. Think of the walls of our cells.
Okay.
And being fully saturated means it resists damage, oxidative damage specifically. It stays stable under different conditions, heat, light, oxygen exposure. Unlike some other fats, the polyunsaturated ones especially, which can sometimes break down into harmful byproducts, C15.0 doesn't really do that.
Ah, interesting.
Its structure makes it resilient, gives a long lifespan inside the body. You can almost think of it as like a structural reinforcement for your cells.
What's really wild about C15.0 then is that even though it seems so important, it's largely vanished from our diets. You mentioned it's called a nutritional orphan. What happened? Why did it disappear?
Yeah, if you zoom out a bit, look at the bigger picture, it seems pretty clear C15.0's disappearance is directly tied to the big shifts in dietary recommendations over the last few decades.
The low-fat craze.
Exactly. That widespread push for low-fat diets, it inadvertently led to a massive reduction in C15.0 consumption. As people started actively cutting back on full-fat animal products, especially dairy, they just didn't realize they were also cutting out this potentially really beneficial fatty acid.
So where can we find it then? If it's disappeared, where does it naturally occur? What should people be looking for if they want to, get more of it?
That's the crucial question, absolutely. Because your body can't really make meaningful amounts of C15.0 itself. You have to get it from your diet.
Okay.
And unlike, say, omega-3s, where you have quite a few options, C15.0 has pretty limited food sources. The main ones are, first, whole-fat dairy products. So think butter, cheese, whole milk, especially if it's from grass-fed animals, that tends to be higher.
Grass-fed, okay.
Yeah. Butter, for example, is maybe about 1% C15.0 by weight, and it makes up maybe 1 to 3% of the total fat in dairy. But, and this is important, low fat or skim milk, they'll have hardly any or none at all.
Right, that makes sense.
Then you've got grass-fed ruminant meats, so beef, lamb, goat fat. They contain C15.0, but usually in lower amounts than dairy, maybe around 0.3 to 0.5% by weight. Organ meats like kidney fat can be sources too. Again, grass-fed tends to have higher levels.
Interesting. What about fish?
Fish is interesting. Some species, like salmon, only have trace amounts, but others can be surprisingly high. Mullet, for instance, is exceptionally high, like 1.56% of total fat. Mackerel has modest amounts. Sardines have small but, significant content. So wild-caught fish can contribute. And finally, historically, traditional animal fats used in cooking would have been a source too.
Okay, and what about listeners who are on plant-based diets? Is there any hope there?
Unfortunately, not really much. Plant-based foods and eggs contain only really tiny trace amounts of C15.0. It's generally far too small to meaningfully support the body's needs. So yeah, a very strict plant-based diet, one without any dairy or fish, would likely lead to very, very low C15.0 levels.
Okay, so given all that and knowing where it isn't found easily, why is it so crucial? Why do we need to worry about getting enough of this nutritional orphan? What does it mean for our health day to day and maybe long term?
Well, this really forces us to reconsider what we thought we knew about fats, doesn't it?
It really does.
The latest research is seriously challenging that old blanket idea that all saturated fats are bad for you. C15.0 just stands out. It seems to behave much more like the beneficial omega-3s than like those traditional saturated fats we've been warned about for years.
Wow. Like omega-3s.
Yeah. It shows these remarkable anti-inflammatory properties, metabolic balancing effects, even regenerative potential. It actively supports your mitochondria. Those are your cell's powerhouses. It provides anti-inflammatory effects, and it literally strengthens your cell membranes, which is super important, especially as we get older.
Okay.
And because your body can't make it, as we said, scientists are now seriously considering that C15.0 might actually qualify as an essential fatty acid.
That's a huge claim, an essential fatty acid that acts like omega-3s. So how does it actually work? Once we eat it, what's going on inside our bodies? What are the mechanisms behind these really broad benefits?
Right. So when you eat food containing C15.0, it gets digested and absorbed efficiently. Then it travels through your bloodstream. But here's the key difference. Unlike a lot of other saturated fats that are mostly just burned for fuel, C15.0 seems to actively communicate with your body's cellular machinery.
Communicate. How?
It gets incorporated directly into cell membranes, especially red blood cells, the membranes inside your mitochondria, even into your fat reserves.
So it's not just a brick in the wall, it's actually sending signals. What kind of messages is it sending? This sounds fascinating.
Exactly. It acts like a metabolic messenger. It interacts with several really key systems that regulate fundamental things like your energy levels, inflammation, overall cell health, even the aging process itself.
Okay, break that down for us. What systems are we talking about?
Okay, first, it influences your genes, kind of like genetic master switches. It activates things called PPAR alpha and PPA delta. These are receptors inside your cells that literally turn genes on or off. And C15.0 activates them, much like some therapeutic drugs do, but naturally.
Wow.
PPAR alpha helps regulate fat burning and cholesterol metabolism, which is good for your liver. PPAR delta boosts muscle energy and improves insulin sensitivity, really important for blood sugar control. So, fundamental stuff.
Okay, that's huge. What else?
It also activates your cell's master energy switch. There's something called AMPK. Think of it like your cell's fuel gauge, tells it how much energy is available. When C15.0 activates AMPK, it sort of mimics a fasting signal for the cell. This encourages efficient fat burning, it triggers cellular cleanup, a process called autophagy, and improves mitochondrial function, basically making your cells run cleaner and more efficiently.
Cellular cleanup, like spring cleaning for cells.
Kind of, yeah.
Yeah.
And then it also seems to act as a longevity signal. C15.0 inhibits another pathway called mTOR. mTOR controls cell growth, and when it's overactive, it's often linked to accelerated aging and unhealthy cell growth.
Right.
By inhibiting mTOR, C15.0 appears to slow down some aging processes, promote cellular repair, and essentially mimics the effects of caloric restriction. That positions it as a potentially really significant longevity nutrient.
Caloric restriction mimic. That's always interesting.
Isn't it? And finally, it strengthens your cell's defenses. Remember we talked about stability. As a saturated fat, C15.0 integrates right into the cell membrane, the phospholipid bilayer. It literally strengthens that structure, makes cells more resilient, and protects them from oxidative damage. This is particularly good for red blood cells, improving their flexibility and how they deliver oxygen. It's like reinforcing the walls of a fortress.
That's an incredible list of functions at the cellular level. It's amazing how these tiny actions can add up. So what does this actually mean for our everyday health, our long-term well-being? Connect the dots for us.
It really is astonishing how these mechanisms build up to tangible health benefits. It creates a stronger, more resilient foundation, starting with things like calming inflammation. It actively reduces those pro-inflammatory signals throughout the body. This helps protect organs, liver, heart, lungs from chronic damage, scarring, fibrosis.
Okay, so less chronic inflammation. That's huge.
Huge. Then there's metabolic balancing. By activating those energy switches we talked about, AMPK and PPRs, it significantly improves how your body handles sugar and fat, better insulin sensitivity, better overall metabolic health.
Good for preventing things like type 2 diabetes.
Potentially, yes, and cardiovascular protection. Studies are showing that people with higher C15.0 levels in their blood have a lower risk of heart disease and stroke. It seems to help optimize cholesterol and triglyceride levels, reduce inflammation in the arteries, and even make your blood vessels more resilient.
Wow. Okay, heart health too.
Liver health is another big one. It's been shown to reduce fat accumulation in the liver, lower inflammatory markers there. It might even help repair the gut barrier, which can prevent stuff from leaking through that puts stress on the liver.
Interesting connection to gut health there.
Yeah. And then cognitive and mental clarity. C15.0 seems to support brain health by calming down neuroinflammation and boosting energy production right inside the brain cells. That could translate to better focus, more stable mood, just better overall cognitive function.
Brain fog lifter, maybe.
Possibly. And then there's the cellular protection and anti-aging aspect. By helping mitochondria work better and reducing that free radical damage, it literally seems to protect your cells from aging too quickly. It delays aging by mimicking caloric restriction.
That longevity angle again.
Exactly. And finally, immune system support. Beyond just inflammation, it seems to modulate immune responses, and it even shows some mild antimicrobial effects. Might help support a healthier gut microbiome by selectively inhibiting some harmful bacteria.
Okay, that's a really comprehensive list of benefits. It almost sounds too good to be true, which inevitably leads to the question, are we getting enough? And maybe more importantly, what happens if we're not getting enough C15.0?
Yeah, you've absolutely hit on a critical point for, I suspect, many people listening. As we said, there's no official RDA, no recommended daily allowance for C15.0 yet. But the research emerging suggests a range of maybe 100 to 200 milligrams a day could be beneficial for optimal cellular and metabolic health.
100 to 200 milligrams. Okay, and what are most people getting?
Well, here's the kicker. Most modern diets, especially low-fat ones or strictly plant-based ones, probably provide less than 20 milligrams a day.
20. That's way off.
Way off.
Yeah.
Far, far below potentially beneficial levels.
So what are the concrete consequences then? If we're running on, say, 10% of what might be optimal, what does that nutritional gap mean for our health?
Right. Because your body can't make it, and it acts like this nutritional regulator, having low intake means your body essentially loses these critical protective effects. That increases vulnerability to a whole range of chronic conditions. And the research is showing pretty strong links now between low C15.0 levels and several specific health risks.
Such as?
Well, first, chronic inflammation again. Not having enough C15.0 can lead to an overactive immune system. You see higher inflammatory markers, potentially an increased risk for autoimmune issues.
Okay, inflammation flares up.
Then metabolic dysregulation. Your cells become less responsive to insulin signals, leading towards insulin resistance. Elevated triglycerides and cholesterol become more common. This increases the risk for type 2 diabetes and causes those energy crashes like post-meal fatigue.
That afternoon slump.
Could be related. Cardiovascular risks also go up significantly. Studies show much higher LDL, the bad cholesterol, lower HDL, the good cholesterol, increased C-reactive protein, which is a key inflammation marker, and a higher risk of high blood pressure in people with low C15.0.
That's a whole cluster of risks.
It is. Liver dysfunction is another one. The risk of non-alcoholic fatty liver disease, or NAFLD, increases. Liver enzymes might go up. Liver inflammation can progress towards fibrosis or scarring. And that poor gut barrier integrity we mentioned can make it worse.
So the liver takes a hit, too.
Definitely. Cellular aging seems to accelerate. Free radical damage increases because the cells aren't as protected. Mitochondria produce less energy, ATP. Cells just age prematurely, and they don't recover as well after stress.
So feeling run down, maybe slower recovery.
Could be part of it. And then brain fog and mood issues. If brain cells aren't getting energy efficiently from their mitochondria, that can lead to low mood, irritability, focus problems, mental fatigue. Neuroinflammation also goes up, increasing the risk for cognitive decline down the line.
Okay, that connects a lot of dots for people, I bet.
And finally, just weaken cells overall. Remember, C15.0 helps stabilize membranes. Deficiency means weaker red blood cell membranes, which compromises oxygen delivery. That leads to fatigue. And cells generally are just more vulnerable to oxidative damage.
Wow, it really does live up to that name, nutritional orphan, when you see all those potential consequences of not having enough. It's like removing a key support beam.
That's a good analogy.
So we talked about the low-fat craze being a major driver. What else contributes to this deficiency? Why are so many people potentially missing out?
Yeah, modern dietary trends are definitely the main culprit. Beyond just the general shift to low-fat and plant-based eating, you've got the huge increase in ultra-processed foods.
Right. They're everywhere.
And they just lack real dairy fats or real meat fats, where C15.0 is found. Also, the heavy reliance on vegetable oils, things high in omega-6 fatty acids, can sort of crowd out or displace sources of C15.0 in the diet and potentially in our cell membranes. And, many people still actively avoid butter and red meat because of those decades of warnings about saturated fats, completely unaware they might be missing out on C15.0's unique benefits.
It's like we threw the baby out with the bathwater, maybe.
Possibly, yes. In
Yeah.
this specific case, it looks like it.
Okay, this is all incredibly compelling, but I know what listeners are thinking because I'm thinking it too. A saturated fat with all these health benefits. We've had it drilled into us for years to limit saturated fats. So let's tackle the elephant in the room head on. What about safety? Is C15.0 genuinely safe? And how exactly is it different from, say, palmitic acid, the one we often hear warnings about?
That is the critical question, and a very understandable one. And the answer seems to be yes, C15.0 appears to be very safe. It's well tolerated at the kinds of doses found naturally in food or used in studies, and crucially, it exhibits these anti-inflammatory and cell-protective properties that are just not seen with typical saturated fats.
Okay.
The current scientific consensus points towards minimal risk, and the evidence is pretty robust now. You look at cell studies, in vitro stuff. Researchers tested C15.0 across 12 different types of human cells at various concentrations. They saw zero cytotoxicity, no cell damage, even when the cells were under stress.
No damage. Okay.
And said they consistently saw cell protection, reduced inflammation, reduced oxidative stress. Then you look at human trials. The first human clinical trial gave people 200 milligrams a day of C15.0 for 12 weeks. Healthy participants. They reported no serious side effects, no concerning changes in liver enzymes. People tolerated it just like you tolerate a nutrient from food.
That's encouraging.
What was notable, actually, was a 15% reduction in liver enzymes in the participants who started with higher C15.0 levels and an 8% increase in hemoglobin, suggesting better red blood cell health.
So potential benefits even in the safety trial.
Exactly. And animal studies back this up, too. Animals fed C15.0 showed significant liver protection, lower liver damage markers, less inflammation, no weight gain, no organ toxicity, reduced oxidative stress, reduced fibrosis. It consistently looks protective.
Okay, so the safety profile looks good, but how different is it really from those other saturated fats? Let's do a direct comparison.
Yeah.
C15.0 versus, say, palmitic acid, C16.0.
Right. It's fundamentally different. And that difference really comes down to that odd chain structure, the 15 carbons versus 16. Think of it like this. Palmitic acid, C16.0, is that common, even-chain saturated fat. In excess, it can contribute to inflammation, insulin resistance, more fat in the liver. That's the one we've generally been told to limit.
Okay, the bad guy in the story, traditional.
Right. But C15.0, with its unique 15-carbon odd-chain structure, it's like its beneficial cousin.
Yeah.
It actively seems to reduce inflammation, lower liver enzymes, protect the liver. It's a game changer because it forces us to stop saying all saturated fats are bad. C15.0 behaves much more like a regulatory molecule, an anti-inflammatory one.
Okay, that's a clear difference. What about C15.0 versus stearic acid, C18.0? That's another common one.
Stearic acid, C18.0, is an 18-carbon saturated fat. It's generally considered more neutral. Some studies suggest it might be slightly protective regarding blood lipids, but there's much less evidence for having these active cell signaling roles like C15.0 does.
So C18 is sort of neutral, C16 can be problematic, C15 is actively beneficial.
That seems to be the picture emerging, yes. C15.0 is positioning itself as an actively beneficial essential fat. It binds strongly to those PPAR receptors, which stearic acid doesn't seem to do effectively. And C15.0 consistently shows these inflammation-reducing properties, protective effects on cells, on liver function, on mitochondrial health, in a way that most even-chain fats just don't. It's not just neutral. It seems to be actively working for your health.
This whole deep dive has really painted C15.0 as a potential game changer, a really unique fatty acid. So what's next? Where does the research go from here? And what could this mean for the future of nutrition, maybe even dietary guidelines?
Yeah, looking ahead, the implications are pretty huge. And the future for C15.0 research looks incredibly promising. We definitely need more clinical trials.
Bigger ones, longer ones.
Exactly. Larger scale, longer-term studies across diverse groups of people. We need direct comparisons with other healthy fats like the omega-3s. And studies looking at specific applications. Can it help manage metabolic disorders? Can it impact aging markers? Can it be used therapeutically for liver conditions? Lots of questions still. And all this research will hopefully pave the way for defining what optimal blood levels actually look like for different health outcomes. Eventually, maybe establishing a daily recommended intake, based on solid clinical evidence, and figuring out what level constitutes a true deficiency, that
Yeah.
could inform future dietary guidelines.
Right. Getting it officially recognized.
Precisely. And you're already seeing growing interest in creating C15.0 enriched functional foods and supplements.
Oh, interesting. Like what?
Things like fortified dairy products, maybe health bars, specialized medical nutrition formulas. There's definitely a push to position C15.0 as potentially the next omega-3, a powerful functional fat with this unique cellular repair potential.
The next omega-3. That's quite a statement. It really does sound like it could be a significant missing piece of the puzzle we've been trying to solve regarding diet and health.
It absolutely feels that way. Pentadecanoic acid, C15.0, it's clearly far more than just another fat molecule. It's acting like a powerful protective molecule that genuinely has the potential to reshape how we think about nutrition and long-term health. It's a cell protector, strengthening those membranes, reducing oxidative damage. It's a longevity promoter through all those pathways we discussed, boosting cellular health and resilience. It really truly could be a missing link that we've overlooked for decades in the complex world of fats. And it might become central to dietary recommendations focused on longevity and optimizing health in the future.
What an absolutely incredible journey into the surprising world of C15.0. We've really peeled back the layers today on this nutritional orphan. We discovered how its unique odd-chain structure lets it act as a metabolic messenger, a protector for our cells, and a really powerful ally against inflammation and maybe even aging. It just challenges so many of our ingrained assumptions about what makes a fat good or bad, really turns things on their head.
It certainly does.
So as we wrap up this deep dive, here's something provocative to leave you with. As we keep refining our understanding of nutrition and we uncover these amazing beneficial compounds like C15.0, are there potentially other nutritional orphans out there? Other overlooked molecules waiting to be discovered that could profoundly impact our health and longevity, challenging even more of our long-held dietary beliefs?
Yeah, and that raises the crucial question. How might recognizing and really addressing these missing links like C15.0 fundamentally shift our whole approach to diet, to preventing disease, and to promoting healthy aging in the years to come? Makes you think, doesn't it?